sent it today after I believe few hours ago I sent it. Anyways, so let us continue with this chapter. In the previous chapter, in the previous class, we did talked about resources, and thereby we saw that resources can be anything that we can utilize, that we can bring into our use right now, and we can benefit from it in any way, in some way. Then further, these resources can be classified as those resources that are natural and the one that are made by humans. For example, you can have a man-made resource. For example, buildings are also kind of resource, but these are man-made resources. Then you have some natural resources like forest, or wind, soil, water, air. These are the natural resources that we are obtaining from the forest, that are we are obtaining from the nature. Then further, we understood that the natural resources can be further categorized into two types: one that is exhaustible, one that is inexhaustible. We learned about these things in the previous class. We learned about fossils, and we also learned about paleontology. What is paleontology?
Study of fossils. Study of
Repeat.
fossils.
Study of fossils, that is called as paleontology. Okay. Then we were talking about fuels also. So what is a fuel? So we say that fuel is basically any substance that will release a good amount of heat, a good amount of energy. Any substance that upon burning gives a good amount of heat and light, that will be called as a fuel right now. So some of the fuels are good, some of the fuels are bad. That's a different case. But normally you have following examples of fuels. You have of fuels. You have coal, you have petroleum, you have wood right now. These are normally some of the examples. Apart from that, there are so many other examples also. Further, fuels can be classified according to their state also. So fuels exist in all the three forms. Fuels can be found in the solid state, it can be found in the liquid, and it can be found in the gaseous state also. For example, we have fuel like coal, firewood, animal dung cakes, charcoal, coke, etc. These are the fuels that are found in the solid states. So they will be existing at the solid state at the room temperature. Yes.
What is
Hello.
coke?
What is coke? See, coke is obtained from coal. Coke is obtained from coal. We have a topic in the chapter that is fractional distillation of destructive distillation of coal. There you will get to learn about coke. Okay, no?
Okay.
Also, Alif, this is the first time you have joined this batch, right, Alif?
Yes.
Okay, okay. You haven't missed much in this chapter, so you won't have any problem. Then you have liquid fuels. For example, petrol, diesel, kerosene. These are some of the liquid fuels, and these are volatile liquids. What does volatile liquid means? That meaning that upon burning, they will produce vapors. When they will be burned, they will directly convert into vapors and will be giving energy right now. So the fuels like petrol, diesel, or kerosene, upon burning, they turn into their vapor state, into the gaseous state. So they are called as volatile liquids. As you might have heard, like petrol is a volatile liquid, meaning that if you were to leave petrol in open, if it is not kept in closed bottles, it will evaporate it will evaporate fast right now. So any liquid that evaporate, all the liquids are volatile in nature, because almost all the liquids turns to their vapor state. That is the thing. Then gaseous fuels are also there. You have examples such as natural gas, biogas, compressed natural gas, coal gas, etc. So these are the fuels that exist in the form of a gas or a mixture of different gaseous fuels. For example, compressed natural gas, it's a mixture of different type of compressed natural gas. It's a mixture of different type of gases. Getting it, guys? Biogas will also have different type of. It also has a different composition. Getting my point now? So gases like biogas, natural gas, they are mixture of gases. For example, just to give you a rough idea, for example, if you were to talk about biogas, so biogas, it's a mixture of methane. It consists of carbon dioxide also, and it will consist of some other gases also. But the major composition is of methane and carbon dioxide. You guys getting my point now? So that in general are
Yes.
the different
So
types of fuels as per
I'm
their
going
state.
to repeat again.
Which one, Sandus? Which topic? All of it.
The all.
Okay, okay. Anyone has any other questions? See,
No, sir.
basically we were learning about fuels. Fuels are basically you have wood, you have petrol, you have coal, you have charcoal, or you have diesel. Upon burning, they give you heat and light. So they are called as fuels right now. It's not like you will, although apart from these substances, there are a number of things that also burns and that gives heat and light. For example, you can consider example of, let's say, a cloth or a plastic. They also burn, they also catch fire, but as compared to these substances, they do not give that much amount of heat and light upon burning. So they are not usually classified as a fuel. Getting my point now? Then talking about the states of fuels, fuels can be occurring in different states. It could be solid, liquid, and gases. These the fuels like firewood, coal, or cow dung cakes, or charcoal. They are known to be existing at in a solid state at the room temperature. Getting my point now? Uh, do tell me what is the room temperature? I mean, what is the normal room temperature? Generally, it is somewhere around how much? 20, 25, 28.
Yes.
Usually, normal
I
room
did 20,
temperature.
30.
25 to 28 degrees Celsius right now. So at this temperature, they are known to be usually existing in the solid state. If the temperature were to increase very higher, like if it goes up like 40, 50, 60, then their state might change. But usually you will find that whenever they are burned, they basically turn to ashes, whether it be coal or firewood or animal cake, dung cakes or charcoal or coke. They usually burn, they usually convert into ashes. That's the thing. Then you have liquid fuels like you have petrol, diesel, kerosene. They are said to be volatile liquids, meaning that whenever they will be exposed to heat, when they are burned, they will convert into their vapor state and will be giving energy, will be giving heat energy. That is the thing about them. Then you had the examples of gaseous fuels like you have natural gas, you have biogas, you have CNG, that is compressed natural gas. Then you have coal gas. Later on in the later part of the chapter, while we would be learning about destructive distillation of coal, you will get to learn coal gas along with coke is produced in that process. So don't get confused. What are these things? Others are, I believe that you get to hear about them on a day-to-day, on a daily basis, on a day-to-day basis. In newspapers or in different articles, they are basically mentioned. See, so talking about gases like natural gas or biogas, they are not made up of just one type of gases. Like biogas is not just made up of methane gas. Apart from methane, it consists of carbon dioxide also. It consists of other gases also. Getting my point, guys? Have you guys seen that at various places biogas plants are installed? Uh, like there would be a chamber that would be placed at different places. Usually, not everywhere. Huh? Like for example, usually what do we see that people would be, particularly for example, if you went to some areas in Delhi, you'd find that people would be throwing the waste in an open area. So that becomes the breeding ground for mosquitoes and lots of bacteria. Many times cattle would also be feeding upon, if they find something edible for them. uh, it's a sad thing to see that many times they would be engulfing the polythenes also from there. So many a times you would see that government would be installing a big metallic chamber structure like this, and in this they will basically ask you to put all the biodegradable waste. So you have kitchen waste, uh, vegetable peels, fruit peels, etc., dead leaves. So you can put that into this chamber right now. And in this chamber, basically all those waste will generate biogas. And that biogas can be used as a fuel. Although biogas production takes place at a proper biogas plant at a large scale, but usually you can find such structures at certain places. Getting my point now? So that biogas, which is produced due to the decomposition of the biodegradable waste, that will be releasing methane, carbon dioxide, and some other gases also. If there's a doubt in it, please do let me know. Okay, should we move ahead? Move next.
Yes, sir.
Then we talked about fossil fuels also. Do tell me, will you count firewood as a fossil fuel? Is
No.
firewood a fossil fuel? No. Why? Why is it not a fossil fuel? Yes, Khadija. Why fossil? Why firewood is not a fossil fuel? Or Aleph, Gauri.
Sir, is firewood a dead like wood?
Fire.
Firewood is not a.
Mm-hmm. Yes, complete. You were saying something. See, basically the thing is, firewood is basically wood that you used to burn. That is basically burnt, for either for cooking or for either for some other purposes in industries. What have we learned about fossil fuels? Yes, Sundus? We learned about fossil fuels that they are formed from the dead remains of plants and animals, and it took millions of years for the formation of fossil fuels. We had the example of coal, petroleum, and natural gas. While firewoods, you can simply go to a forest, cut down the trees, then you'd have some wood to burn. That is called as firewood. So that's a simple difference between the two. Yes, Chakrika, how are you? Then we learned.
Okay, so how are you?
Yes, I'm good. Then we learned, why do we need fossil fuels? So there are a variety of purposes for which we need fossil fuels. For example, need it to cook food. We need it at various industries. We need fossil fuel to generate electricity. Some of the fossil fuels would be used as a rocket propellant also. Getting my point? Then another topic is that, what are the characteristics of a good fuel? Like we have learned about different types of fuels over here. See, we learned about coal, firewood, animal dung, different types of fuels we have learned about. But are all of them good? Hmm? Are all of them good? How do we categorize? How do we um, distinguish them? How do we categorize whether a fuel is good or bad? So a fuel should have a following characteristics. For a fuel to be a good fuel, it should have the following characteristics. It should be economical, that it should not be too expensive. It should be available easily in nature. It should not emit the poisonous gases upon burning. Right now, then it should not produce any leftovers. Then another thing is that it should produce large amount of heat with respect to its mass, meaning that if you were to have just a small amount of mass, it should produce large amount of heat. Or in another terms, we say that it should have a good calorific value. Getting my point? For example, if I were to talk about different kind of fuels, for example, liquefied petroleum gas, hmm, it has a calorific value of 55,000. Compare it with kerosene. Kerosene has got a comparatively less calorific value. It has normally a calorific value somewhere around 45,000. Getting my point? Okay, by the way, first of all, you should understand what a calorific value is basically. Okay, now let me just tell you. Calorific value. See, calorific value is simply the amount of energy which is released when you burn 1 kilogram of fuel. Getting my point? Amount of heat energy released after burning 1 kilogram of a particular fuel, that is called as calorific value. And the energy that is released, it is measured in terms of joule. Is that clear to all? Let me write
Sir,
this.
can you repeat it again?
Yeah, I'm writing it also. See, it is simply the amount of heat energy produced on the complete combustion of 1 kilogram of a fuel. Combustion here basically refers to burning. Okay, now. So let's say you have 1 kilogram of petrol or one. Let's forget about liter or other units. Just for convenience, let's say that we are taking the unit as kilogram. Okay, now. So for example, if you were to burn 1 kilogram of petrol, also one more thing, let me write that also. Let me write about its unit also right now. So unit of calorific value is 1 kilojoule per kilogram. 1 kilojoule per kilogram. Okay, now. What is joule here and what is kilojoule? Let me tell you that. See, joule is the unit of energy, and then 1000 joule is equal to 1 kilojoule. Is that clear to everyone? The heat
Yes.
that is released, it's a form of energy, and that form of energy is measured in a unit called as joule. And you have the bigger unit of joule. If you have 1000 of joule, it is called as 1 kilojoule. So basically, calorific value is the amount of heat energy that will be produced after complete combustion of a given fuel. Also, you should keep this thing in mind also. While we talk of it, we also consider the normal temperature. The condition has to be normal while we talk about calorific value. Meaning that, say that if moments ago I was saying that calorific value of petrol is 55,000 kilojoule, right? I said that moments ago. So while the calorific value of petrol was measured, so while measuring it, the conditions were normal. Like it's not like the room temperature was too much or the pressure in the room was too much. So under the normal conditions, we talk about calorific value. For example, let me give you some of the a list of some calorific values. For example, let me add one more page over here. For example, if you were to talk about the amount of heat that is released upon burning cow dung.
So the last slide.
Yes.
The last slide, can you show it again?
Okay. Okay. See, listen to me as well what I'm saying. If you were to burn 1 kilogram of a cow dung cake, it would release around 6,000 to 8,000 kilojoule of energy. Getting my point, Chakrika, Sundos, Khadija, Gauri, and Aleph.
Again.
I'm writing it. Shall I change the page? You guys can write it later on. I will give time to write it. Okay, now first let me complete this. Calorific value. What is the unit? Kilojoule per kilogram. How do you read this? Kilojoule per kilogram. Okay. So guys, for cow dung, it is going to be somewhere around 6,000 to 8,000. Let's say, what about coal? For coal, it would be somewhere around 25,000 to 30,000 or 33,000, whatever you can take. Let's say 30,000. Now let's say if you were to have LPG gas, liquefied petroleum gas, the amount of the calorific value of liquefied petroleum gas is 55,000. Or let's say if you were to talk about hydrogen, yes.
So for LPG, high calorific value is an advantage, right?
Repeat again.
So for LPG, liquefied petroleum gas, high calorific value is an advantage, right?
Exactly, it's an advantage.
Okay,
exactly, it's an advantage. Okay, now I have mentioned only some of them. Like you have other fuels also, like diesel, methane, kerosene, etc., petrol. What basically I wanted to tell you, you have taken the same mass of all of these fuels. It's not like you took different amount of hydrogen or LPG or coal. All of them were of the same quantity, that is 1 kilogram. But yet you get to see that there's a difference in amount of heat generated after complete combustion of 1 kilogram of the given fuels. So do tell me which one is better out of the 4 given fuels here. Is it A, B, C, or D?
B.
Hydrogen, obviously. Everyone agrees to this.
Yes, sir. Sir,
So this is
yes,
the
sir.
best. Yes.
if we combine all the fuel, what will happen?
It's a good question. If you were to combine all the fuels, see, in that case, it will basically what will happen now. You have to take the aggregate value of the amount of heat that will be released. Right now, it's not like the fuel will have a very better fuel, because the properties of different fuels are different from each other. For example, upon burning cow dung, it will leave residue. It will leave residue and it will release smoke also. Same is for coal also. LPG and hydrogen are good fuels. So the fuel that we will be having, first thing is that it will leave residue if you were to mix all these fuels. Another question is that whether that fuel will be a working fuel or not, that also has to be considered, because their compositions are different. So after mixing all of them, whether we will be having a working fuel or not, so that's also a question. Even if you were to have a fuel that will be working, so that's its calorific value will not be very good. It will not be very good. Like it will not be equal to that of hydrogen, that is for sure. Because in that you have mixed bad fuels also, like bad quality fuels like cow dung or coal. So the calorific value will go down. That's the first thing. Second thing is that it will leave some residues also. Like hydrogen on LPG gas, they leaves almost no residue after combustion. Do you find that after, like in your kitchen, when LPG is burnt, is any residue left? Almost no residues left now.
Sir.
Getting my point now. So that is the thing which will be happening. Apart from having a good calorific value, it should be easy to transport and handle. It should not produce a bad odor, meaning it should not give a bad smell. Then it should be clean and should not produce many ashes. It should not ignite easily at room temperature. So there that we then you have a new concept here, that of ignition temperature. Ignition temperature. See, ignite easily. So thereby you should learn about this ignition temperature. Let me tell you what this ignition temperature is. See, different fuels require different amount of heat in order to catch fire. Different fuels would require different amount of heat to catch fire. For example, let's take example of this one. See, if you were required to burn petrol, so the amount of heat, that is the minimum amount of heat that will be required to burn petrol, it's 246 degrees Celsius, somewhere around that, 246 or 247 degrees Celsius. Or say that if you want to just burn a piece of paper, it will require around 230 degrees Celsius. Getting my point, what I'm trying to say? Yes, you have a question?
If we boil petrol what will happen?
If we
If we boil petrol, what will happen?
boil petrol, what will happen?
Ye-
Is that the question?
Yes.
Okay, see. If you were to boil it, basically what will happen? I believe that it would be very explosive reaction. If you were to do so, it could be very explosive.
Okay.
It could be very explosive. Like for example, if you were to look at the boiling point required for petroleum, now it is very high. Like it is more than 200 degrees Celsius right now. And if you were to boil the petrol, basically what will happen? It will also depend upon the amount of petrol you have. That is also one of the factor. But normally, it could level down the whole building. Like if where the person is living, and if there's a good amount of petrol, and if you were to boil it, so basically that will release lots of pressure. It will release lots of pressure and can level down that building. It can destroy the building, or it can cause a. It will be a very explosive reaction. So that can happen.
Okay, sir.
Okay. Anyways, we were talking about ignition temperature. So ignition temperature is basically the minimum temperature that is required to burn a fuel, regardless of the fuel you have. Getting my point? So I was telling you that in order to burn petrol, you need a temperature of somewhere around 250 degrees Celsius. Or to burn a piece of paper, you would require 230 degrees Celsius. Right now. Is that clear to everyone?
Yes. Yes.
Yes,
The
sir.
minimum temperature required to burn a fuel. For example, as I told you, that of petrol, the ignition temperature is 246 to 248 degrees Celsius. And that of a piece of paper, it is 230 degrees Celsius. So hope you guys are getting it. So if I were to provide 100 degrees Celsius temperature to petrol, it will not burn. Right now, you guys might be thinking that how much of temperature is generated while burning a matchstick. You should think about this. Ever thought about this? See, whenever a matchstick is burned now, the it gives a very small flame now, produces a very small flame, but the temperature of that flame is somewhere around 600 to 800 degrees Celsius. Getting it, guys?
Yes, sir.
Matchstick temperature. So hope it is clear. So we learned about fuel. What are the good qualities of a fuel? We learned about that right now. Now let's learn about coal. In fact, we did learned about coal, I believe, in the previous class. We already did this now. We talked that coal is the fossil fuel formed from the dead remains of dead plants. Here's an animation to help you understand it better. See, you can see that heat and pressure is acting upon this, and over the course of millions of years, they were um, they went to deeper layers of earth. Sand and silt and various other things started to accumulate over them. Here, this is the plant, uh, and the plants have died, and their matter are now settling deeper and deeper under the earth. And gradually, they are exposed to heat and pressure also. Apart from heat and pressure, we learned that biotic agents of nature, like microbes, will also help to decompose them. So that is also acting upon it.
Sir,
So we learned, yes,
what is peat?
peat. Peat is a poor quality of coal. Right now, see, if you were to dug deeper in the earth, you will have good quality of coal. See, if you were to go deeper, you will have better quality of coal. In the upper layers, poor quality of coal is found. Right now, so in the deeper levels of the earth, carbonization process has been going on for a long period of time. Right now, So the rate of carbonization that has happened in the lower levels or in the deeper levels of coal is more. But the amount of carbonization that has happened in the upper layers of coal reserve, it will be slightly less because that is still under the process of coal formation. Is that clear to everyone? You guys getting it now what I'm trying to say?
Yes.
So biological
Yes,
and
sir.
geological factors have helped in the formation of it. And we talked about the composition of coal also. We learned that coal mainly consists of carbon. Apart from carbon, it will consist a small amount of hydrogen, sulfur, nitrogen, and oxygen also. Then we learned about coal mining also. Right now, we learned about coal mining. So thereby we learned that basically coal mining is the extraction of the coal from the ground. That what coal mining is. We had two types of coal mining. Let me write this is extraction of coal from the ground. Okay, I have one question for you. Which country produces the most amount of coal? Meaning that where are the major reserves of coal found? Which country? Any idea?
No, sir.
The country to produce maximum amount of coal
China.
is it? Repeat.
China.
China, exactly. China produces, it's the largest coal producing country in the world. Getting my point now. So that is the thing. Okay. What about India? What is the rank of India in terms of coal production? Any idea? Huh?
Surface.
No, sir.
India is, I believe, second or third, I believe, in terms of coal production. Second, third. As of now, I think what I know, it is for sure India is in the top four coal producing countries. Kindly please check that after the class. I think it is actually the third largest coal producing or might be the fourth largest coal producing country in the world. Okay, now? Okay, we'll let you know in the next class. We were learning about the coal mining. This one is the open cast mining. So mining in which coal is extracted from the earth's surface, basically from near the earth's
Yes,
surface.
India produces, like, India's in top second place.
Top second place. Okay.
Yes, sir.
Okay. Thank you, Chakrika, for letting us know. Good.
Okay.
So we were learning about this open cast mining right now. So it's a near surface mining of the coal. Hmm. Then you have this tunnel mining also, right? Underground mining in which coal is extracted from deep inside the earth's crust, and it is far dangerous than that right now. Now do tell me this thing that how open cast mining is different from tunnel mining. Hmm. Which is, like, you see, which method is more suitable for extraction of coal? Obviously,
Tunnel mining is easier.
Surface mining.
which one? Open
Sir,
cast mining. Repeat again.
So I said surface mining, but someone said something before me.
Okay. See, open cast mining is a better option. It's a faster option right now because you get to see that here the miners are not under the risk. They are not exposed to much risk right now. Also, it will depend upon the geographical factors also, whether it has to be open cast mining or um, whether it has to be a tunnel mining. It will depend upon the geographical factors also, right? For example, underground mining is more suitable for extracting resources that are deep beneath the surface. Try to understand it in this manner. Let's say this is the earth's crust, These are the Earth's crust. And let's say deep inside the Earth's crust, here you have the coal reserve. And here you have the coal reserves like this. Do tell me in which one you will be doing the tunnel mining, in A or in B?
In B. Sorry.
Tunnel mining, have a look at this. This is tunnel mining. You build deep tunnels underground and you have surface mining. Others
So
also
can
tell
you
me,
repeat what's the question?
my question is that these are the coal reserves. These are coal reserves, and this is basically Earth's crust. This is also coal reserves. So you want to do tunnel mining. Let's say, I mean to say that in which one, is it in A or B, in which one tunnel mining should be done? That's the question.
B. Sir, B.
Exactly. So you can simply dig a tunnel to this coal reserve and you can simply take it out. While for this one, there's no need to dig the tunnel simply. It can be extracted by the open cast mining. So that is the thing. Next, let us learn about what are the different types of coals we have based on the carbon percentage in them. So these are the following examples of different types of coals as per the amount of carbon found in them. All right now. So the first one you have is peat. Moments ago we were talking about peat, if you guys remember, like it is found in the upper layers. If you were to look at this image over here, see what do you observe in this? You can observe that peat is found in the upper layers right now. So as you will go down, as you will go to the deeper layers, so there you will be having better quality of coals. So there are different types of coal. Yes.
So how do they find the percentage of coal present in the types of coals?
Percentage of carbon, you mean to say?
Yes, sir. The percentage of carbon.
Okay. How do they find the percentage of carbon in coal?
Yes.
I believe that there must be some method to this. I think there must be some scientific method in order to find the percentage of carbon. They would be taking samples of coals. They would be studying it under the lab. They would look at the mineral composition of the coal. Right now. So as per that, they would come up with this, that this type of coal consists of this much of carbon in it. So they would be testing various samples of coal under the laboratory. That's how they would get to know this. Okay, Chakarika. Another thing
Yes, sir.
you guys should know, as coal gets older, the carbon content in it is higher. As coal gets older, the carbon content in it will be increasing. It will be higher. Getting my point now? So when coal will be burned, in which carbon content will be higher, it will leave less amount of residue. It will burn properly. Right now. Now talking about what are the different types of coals as per carbon percentage, you have the following. This chart will not give you the proper idea regarding the different type of coal as per the carbon percentage. I'm writing down the different type of coals as per the carbon percentage. Okay, now. So these are the ones which I'm going to write over. The first one is going to be peat. I'm writing in an ascending order. Okay, now we have peat. After peat, you're going to have lignite. Then after lignite, you have subbituminous coal. Subbituminous coals. After subbituminous coal, you would be having bituminous coal. And then The finest quality coal is anthracite. Talking about peat. In peat, you will be having, if I were to talk about amount of carbon only in it, I'm not talking about another components found in it. Right now, we are focusing only on the carbon percentage. So you can ignore other things as of now. Like you have sulfur, hydrogen, oxygen, etc. Talking about peat, the carbon content in it will be less than 60%. Less than 60%. Then lignite, it will be having somewhere around 65 to 70% of carbon in it. Talking about subbituminous, it would be having somewhere between 70 to 76% of carbon in it. Getting my point now. Then talking about bituminous, it would be around 76 to 86% of carbon. Then talking about anthracite, it would be 86 to 92 percentage of carbon only. You guys getting this now? So obviously, which one is the best? Obviously, that is anthracite. If you were to talk about peat, peat is very soft. It is soft, not very soft, but it is usually soft. It is brittle in nature, meaning that it will crumble. It is crumbly. It is crumbly, meaning that even you with some amount of force can break it. Right now. So thereby, one more thing you should learn, that while in the process of coal formation, peat is the first type of coal. It's the first step in the formation of coal. Getting it now, Sandosh, Chakrika, Khadija, Gauri, and
Yes.
Aleph. So peat is the, although I'm not going to write these things, just listen to this right now, because you can understand it in that manner. There's no need to write this down. Just listen to me properly. As I was saying, that peat is a soft, crumbly, dark brown substance that is formed from dead and partially decaying organic matter. Another thing is that it's the first step in the formation of coal. It has the lowest carbon content in it. So thereby the calorific value will also be low. Calorific value of peat is also going to be low. Talking about lignite. Lignite is also one of the coal that has a very low quantity of carbon in it. So the first two, peat, lignite, they both are said to be the lowest quality of coal. All right now, that is the thing. Then talking about subbituminous. Subbituminous, its color would be usually gray, black, or dark brown in color. As compared to peat and lignite, it shows a higher carbon content in it. All right now. Now, thereby, keep this thing also in mind. If coals like, if you were to see like subbituminous coal or bituminous coal, if they were to remain for more time period under the earth, they would also be becoming a good quality coal. Like they on, like if you were to talk about anthracite, anthracite was once peat. Now, anthracite once it was peat. Getting my point? What I'm trying to say. This peat, this peat that can also later on become lignite, subbituminous, bituminous, and then finally it can also become anthracite. So it's a gradual process. We have learned that carbonization is a gradual process. So different types of coals, if they were to be talking about the first four category of coal, if they were also be left under the ground for another for millions and millions of years, so they will also be becoming better coals now. Hope you guys are getting what I'm trying to say. Talking about bituminous coal, this is the second highest quality of coal, and that has a carbon percentage of around 76 to 86%. All right now, in this moisture content will be low. Also keep in mind that the poor quality coals like peat and lignite, in these kind of coal, moisture quantity is usually higher. Okay, now, so you will find that upon burning, they will produce lots of smokes. Am I clear to everyone? While the good quality coal, like bituminous coal or anthracite, they lack moisture, so they will not produce lots of smoke. Talking about anthracite, this will be usually very dark in color, uh, and it's the highest quality coal, and it is very hard since it does not have moisture in it, and has a carbon percentage of around 86 to 92%. It is hard. It is the best quality of coal, and upon burning, it will give lots of heat. It will reach a very high temperature. And apart from these properties, it is also the oldest type of coal, isn't it, guys?
Yes, sir.
Getting my point now. So hope you guys are getting it. Any other questions from this? Please do let me know. If there's any question, please do let me know. Then you
Sir,
have these things also like graphite.
graphite is in the pencil.
Exactly.
So it is flammable?
No, it is not flammable. Okay, no? It is not flammable. Graphite has a high ignition temperature. It has a very high ignition temperature. It requires a temperature close to 900 degrees Celsius. Okay, no?
Okay.
Like talking about the different type of fuels which we have learned so far, like petrol, LPG, they don't have this much of ignition temperature. It is usually around 200, 300 like that. But to burn graphite, you have to increase the temperature to more than 850 degrees Celsius. It has to be close to 900 degrees Celsius. Also, I did told you that even the matchstick, it generates a temperature of only 6 to 800 degrees Celsius. Okay, anyways, uh, talking about graphite, apart from using in pencil, it is used in it has got other uses also. You guys know, like it is used as a dry lubricant also. Graphite is used as a dry lubricant also.
Sir, what's a lubricant?
Yes,
What's a lubricant?
lubricant is something that is used to reduce the friction. Okay, na? Lubricants such as oils, for example, grease, they are used in vehicles, different appliances, in order to minimize the friction and avoid the wear and tear of the objects. For example, it would be used in bicycles, motorcycles, cars, etc. So that is the thing. So at some places, dry lubricants like graphite is used. If you ever touch graphite now, if you were to have a powdered form of graphite, it will be very soft to touch. Huh? Right now. So for example, try to understand this thing. For example, many for most of the equipments we use oil-based lubricants, especially right now. So where do we use dry lubricants? Dry lubricants such as graphite. It has an ignition temperature of 850 degrees Celsius. In order to catch fire, it requires this much of temperature. So machines, some machines are operating at a very high temperature, let's say. Some machines generates lots of temperature. So thereby you can't use the fuel. You can't use the oil because oil can catch fire. So there you will be using this dry lubricant. You will be using graphite as a dry lubricant. You guys getting my point now? What I'm trying to say?
Yeah.
Okay, na? So graphite will also be formed due to the same process of carbonization, due to the same process through which all of these different substances went. Okay, na? But we don't use it as a fuel. Talking about what are the different uses of coal. So coal is used to cook food. It is used in the thermal power plants in order to produce electricity. Apart from that, also it is used in various other industries also. Once it was used to run the steam powered railway also. Once it was used to run steam powered railways. All right now. Okay. You guys tell me who invented a steam engine? Yeah, any idea? You guys ever learned about this? Or basically, just tell me
Sir,
this
his name
thing.
was
When did it came?
Thomas.
It was
Thomas
Tom.
something.
Some. The name was something like Thomas. Thomas Newcomen, I think. Thomas Newcomen, I believe. Uh, so it was invented almost 300 years ago. It's been more than 300 years ago. More than 300 years since the invention of steam engine. Right now. Anyways, let's continue further. Then you have fractional destructive distillation of coal. Let us understand what basically happens in this destructive distillation of coal. So far, we have learned about different types of coal based on the carbon percentage in them. Now let us learn that from the coal, what are some byproducts that we can obtain, and where do we use them? What are their properties right now? So while you would be processing the coal, it will yield different byproducts, like coal will be yielding coke, would be having coal tar, would be having coke, would be having coal gas, would be having coal tar. Right now, these are the essential components that you obtain after the destructive distillation. Do tell me, all of you would have studied about distillation, right? You must have studied about distillation in your previous classes.
Yes, sir.
Okay, anyone do tell me what is distillation? What is the process of distillation? What happens in it?
It's like separating liquids.
Yeah, you can separate the liquid in this way. Very good. It is one of the technique used to separate the liquids. But separate the liquid from a solution. For example, if you were to have salt and you have water, you can separate it using the distillation method. See, distillation, the process of distillation involves two steps. First of all, you would be boiling. Later on, you would be cooling that vapor. Let me get a setup of distillation to give you a better clarity. Why I'm telling you to understand about distillation, because that will help you in understanding destructive distillation of coal. Meanwhile, if you guys can recall the process, please do tell me. Chakrika, Sundus, Adija, you guys must have learned about this in your previous classes, huh?
Yes, sir.
See, here what you taken. See, you have some salt particles in it, and this is water. You want to separate the water from it. Okay, no? Or there could be some other components in it also. As of now, just consider you have salt and water, and you have to separate them. Huh? So with the help of a burner, there you would be having a burner, and you would be burning it. Here, instead of burner, we have some other equipment. Okay, no? So you are boiling the liquid in it, and the vapors will be rising up. uh, it will go into this in this condenser. This is called as condenser. This structure is called as condenser, in which cold water is running. You see this pipe? Look at this pipe. In this pipe now, cold water is flowing. So thereby this cold water keeps this glass chamber, that is condenser, cold. And you know that when vapors comes in contact, when vapors comes in contact with cold temperature, I mean to say that whenever the temperature will be low, vapors will convert it into liquid. So this water vapor that is rising up, when it goes into the condenser, it converts into water droplets. So condensed water will start to fall into this, and hereby you can collect it. That is what distillation is now. So it's one of the separation technique which is used to separate the liquid from a mixture. Here we have separated the mixture of salt and water. Getting my point, guys? So that is the thing. It is used in the process of purification of water also. You must have learned about purification of water, where you would have learned about sedimentation, decantation, filtration.
Sir,
So there, but distillation was
Yes, sir.
also one of the process.
sir, only water and salt is um,
Hmm. No,
distillable.
that's not the case. You have various other examples of distillation. We have so many other examples. For example, distillation would be done to separate two different kind of liquids also. Right now, for example, say that there are two different liquids which have got different boiling points. Say that in this, if you were to have two liquids, let's say liquid A and liquid B. Liquid A has got a boiling point of 100 degrees Celsius. This has got a boiling point. This is 110. This is 120 degrees Celsius. So you want to separate them, but both of them are inseparable in such a manner like manually you can't separate them. Getting my point? Manually it is kind of difficult to separate these two liquids, and these two liquids have got different boiling points, different boiling temperature. So first of all, I will heat the mixture up to 110 degrees Celsius. So all the this liquid A will turn into vapor and will go into this condenser, and I would have stored it. Let's say that this much is liquid A. Now I will raise the temperature to how much? You guys tell me.
200.
Why 200? It's 120 degrees Celsius now.
120.
120. So now when I will raise the temperature to 120, so thereby vapors of this will be rising up. Or simply I can leave second liquid in this glass, and I can simply take it out from this glass later on. That can also be done. Or if I were to bring the temperature to 120 degrees Celsius, that will also rise up. The vapor will rise up, it will condense and will be stored in another glass. So that is the thing about this. Then why did we talk about destructive distillation? Because something kind of similar will be happening in the destructive distillation of coal also, although it will be very much different. See, in this process of destructive distillation of coal, what will be happening? You will be burning the coal in absence of oxygen. In absence of air, you would be burning this. So what will happen? The sample of coal will convert into a powdered form that will be called as coke, and all the moisture, all the vapor from the coal will evaporate. If you can recall from this, vapors were coming out of this mixture now. Same thing will be happening. From this coal, vapors will start to come out, and it will go into this chamber, into this test tube. And here you have taken water. So vapors are now coming in contact with water, and it will convert into coal tar. Right now, let's do one thing. Leave this topic for the next class. We'll be discussing this topic in detail in the next class. It will take some amount of time to cover the topic. Okay, na? Okay, so that's it for today. If you guys have any other doubts, please do let me know.
No doubt, sir.
Okay, then we'll be meeting in next class.